Hello, welcome to Earth Science. We are going to do minerals today, so let's share screens and get started. So remember that this is going to look a little bit different depending on when you're viewing this, but you're always going to go to the modules page and then our lesson page for the day. So look for the current week, the current day. We're going to look at minerals today. So you're going to start with bell work, then you're going to have a video to watch, notes to take, an assignment to do, and remember your assignments are always posted down here in the assignment section as well. Please make sure you're always going through the entire lesson so that you don't miss out on information that will help you figure out the homework. So you have two things to turn in today, the bell work for Geology Jobs and the Minerals Flipbook assignment. We'll go into the Minerals Flipbook at the end of this video. I will put a timestamp bookmark in the description so you can jump to it. So if you want to do notes on your own, you can skip through that section of the video. So let's take a look first at the Geology Jobs bell work page. So for Geology Jobs, you are going to be going to this link, and it's going to give you information about careers in geology. So you are going to look through this information. It's going to take you to this page. You have some links about geology jobs. There are others besides this as well. One of them that we learned about during the video was a volcanologist that studies volcanoes. But look through these, see if there are any that interest you. These are clickable links. There's information down below on what it will take to get those jobs. Click the links to go to those jobs specifically, and you can read about those jobs specifically. If there's a different geology job you would like to learn about, you are welcome to go to those as well. This is just a way to give you an idea and a jumping off point to start this assignment. So here's that link, and then you're going to come in, you're going to hit reply, and you're going to give us information about the job you chose. Answer that here. Give us the information we need. Make sure you put it in US dollars. It may be in British pounds on the website that you go to. Use Google to transfer it over to English dollars. Doesn't have to be exact, but give us a rough idea. Click reply, and then once you've done that, you'll be able to see the posts from your classmates. If you're the first one, you'll have to come back later to respond to someone else. But do make sure that you respond to a classmate so you can have some conversation and interaction with each other. Once you've done that bell work, you're going to watch this video here. It is about 5 minutes long about dangerous minerals that are found on Earth. It's the top 10 deadliest rocks. So you're going to leave my video paused while you do Geology Jobs bell work and watch this video. Then you'll come back to do your minerals lesson and take notes over the presentation. Watch the information about how to do your flipbook, and then you will be free to go to work on your flipbook and get it submitted. So pause me, take care of the bell work and watch this video, and then come back and we will start the notes. So vocabulary that you need to know about. A grain, that is going to be a unit of measurement for us. It's basically one particle. So a grain is similar to like a particle of sand. So 5 grains is 5 particles, equivalent. Rock, that is a solid combination of minerals or mineral materials. So you put a bunch of minerals together, squish them all up, heat, pressure, form a rock. Inorganic. We've talked about organic and inorganic before. Organic is living, inorganic is not living. Not living doesn't mean dead, okay? Not living means it is not and has not ever been alive. It did not come from something that was alive. So inorganic is things that are not able to be alive and did not come from something that was alive. Rocks, water, okay? Those are inorganic things. Organic things would be like the dead leaves on the ground, the live trees. Those are all organic. So you need to know that inorganic is not alive, never alive, did not come from anything that was alive. As always, if we're going through these slides and I go a little bit faster than what you are able to follow, you can pause the video, finish the slide that you need to finish, and then restart the video where you left off and continue on. So always feel free to pause the video if you need to finish a slide. So what is a mineral? A mineral is a naturally occurring inorganic solid. So it comes from non-living materials and it occurs in nature. It's very structured, it's ordered. So the atoms that make it up arrange themselves in a very orderly fashion. They have a shape and a structure to them. And that structure is always going to be the same for the same type of mineral. So if you have pyrite, the crystal structure of pyrite is always going to be the same no matter what size the sample is. You can have a little piece that's, the size of a penny, or you can have a piece that's the size of a softball, and the crystal structure is going to be the same. The atoms are always arranged in the same fashion. Now, if you have the pyrite compared to a diamond, that's going to be a different crystal structure in each of those. Inside a mineral, you have different elements. So the composition of those elements is what makes the mineral unique. So you will always have the same types of elements in the same type of mineral, but you can have different proportions of those elements in the same type of mineral. So you can have, example, a quartz crystal. It might be white or pink or blue, and those different colors come from the different proportions of elements in them. They all contain the same elements, just in different amounts, and those different amounts will give you the variation in color and some of the other properties that can change. Building blocks of rocks and identified by properties. So whereas an atom is the building block of matter, a mineral is the building block of a rock. So minerals are contained within rocks. We identify minerals based on their properties. Some properties are unique. Other properties can change, like color. And some properties are going to be shared among different minerals. There's only so many properties to look at, so some of the minerals are going to have similar properties. So let's take a look at what those properties are. The first one we've talked about actually is crystal structure. It's the geometric shape that forms the crystals. The size can vary, but the shape is always going to be the same. This is how the atoms order themselves or put themselves together. And it's always going to be the same shape for each type of mineral. So you can have the cubic in one mineral. You might have this larger cube. You might have this kind of kite shape in another mineral. Okay, but it's always the mineral that has this kite shape as its crystal structure. It's always going to have the kite shape as its crystal structure, no matter what size it is. The second one is color. Color is not as reliable as any of the other characteristics. This is the main characteristic that's going to change even within a mineral. And we talked about quartz being different colors. There's other minerals that can be different colors as well. You have that element composition that we talked about, and the different amounts of each element can determine what color the crystal or the mineral is going to be. So for example, in quartz, you can have pink, clear, purple, there's green, there's blue, there's yellow quartz, all different colors of quartz. Almost any color of the rainbow can appear when you're looking at quartz. Fluorite is another example. It comes in purple, blue, and green. There are some other varying shades and smaller amounts. You can have a single fluorite crystal that has multiple colors in it. It's kind of a cool element. It's one of my favorites. And again, that's due to the different amounts of the elements that are inside of it. A quartz is a quartz. It has the same elements no matter what color it is. You're just looking at different amounts. Okay, the next one we're going to look at is streak. We've got a little picture down here of a couple of minerals and the streaks that they leave behind. And what you do to find the streak of mineral, it's basically the color of the powder that it leaves behind if you scratch it down a porcelain plate. So you take the rock and you're just going to rub it on the plate here, just gently. You don't have to push very hard. And it's going to leave behind this dust trail. And the color of this dust trail here, that is the streak for the mineral. It may be the same color as the rock. It may be a different color than the rock. So you can see this one on the right. It's kind of a reddish brown colored rock, a burnt sienna color, and the streak is a very similar color. The one on the left, you have a gray rock and you have kind of this goldish brown streak to it. So it's not always going to match the color of the rock or the mineral. And what you're looking at when you scratch these look like giant rocks. They are actually mineral samples. So you're looking at the mineral content. Density is another common thing that we look at. We are not going to test density in our labs. However, you do need to be aware that density is a property of minerals. You have the chemical composition is what determines the density. The higher the atomic mass of those elements, the higher the density of the mineral. The next property is luster. Now, luster is basically how the mineral reflects light. There's two main categories. These are our big umbrellas. So you have metallic and non-metallic. So metallic means it's shiny. It looks like the surface of a metal. Okay, so it's going to be chrome looking, or it might look like gold. It might look like copper, but it's going to be shiny and it's going to reflect a lot of light. Non-metallic is anything that is not shiny. It does not look like a metal. We've got a couple examples down here. We can have pearly, which is almost like a shimmery opalescent kind of look to it. It's not like a solid looking color. It can be greasy. It looks almost like it has a coating on the top of it, and it feels a little bit almost slimy, but not quite. It doesn't come off. And then you have glassy over here on the right. It is super clear. It's very see-through. You can generally, hold it up in front of something and see all the way through it to whatever's underneath. It doesn't have to be clear or colorless. It is clear to look through it, but it doesn't have to be colorless. You can have a glassy mineral that has a blue color to it or a green color to it or really any color to it. So when I say clear there, it doesn't mean no color. It just means it's not clouded over. You can see through it. There's not a picture of an earthy sample on here. The earthy is going to be more of it's a solid rock-looking mineral, but it feels almost like it's gritty, or it has like a dirt coating on it almost, even though it doesn't come off. So our next property is hardness, and this is the main one that we're going to focus on in class. We can test for hardness very easily. We can test for streak very easily. You can see the luster fairly easily. And again, hardness is an easy one to test. We have some mineral kits that we're going to use. We're going to do a mineral identification lab. Virtual students will do the online lab. In-person students, it's going to depend on timing and the availability of our lab kits. Because of COVID, we can't reuse materials like that. So we'll have to see how many students we actually have in the building at the time. But we do have a virtual hardness test lab, a virtual properties test lab that we're going to do at a minimum. So hardness is basically the resistance to scratching. We measure it based on the Mohs hardness scale. It's a scale of 1 to 10, with 1 being the softest, 10 being the hardest. So we've got an image here that gives us information. It came from the National Park Service. It's a public source image on their site. So we've got this talc is here at the bottom at a hardness of 1. Diamond is at the top with a hardness of 10. So resistance to scratching at diamond is going to be very, very hard to scratch. Almost nothing is going to scratch a diamond. However, if you have a talc sample, that is likely to scratch very easily, and it may even like crumble apart on you. It's super, super soft. On the right-hand side, you have some common objects that have those hardness levels. The easiest one, obviously, is going to be the fingernail. Your fingernails have a hardness of 2.5, so if you scratch a piece of talc or gypsum with your fingernail, you'll leave a mark on those. And the way the hardness scale works is it's resistance to scratching. So if something will scratch the mineral, that item is harder than the mineral. If it doesn't, the mineral is harder than the item. And for most items, you're going to scratch the item on the mineral. So the masonry drill bit at 8.5, the steel nail at 6.5, your knife or glass plate at 5.5, a copper penny at 3.5. Those are items that you're all going to be able to scratch on the mineral itself, with the exception of the glass plate. We will be able to scratch glass plates and the ceramic or porcelain plates as well. When you do the plates, you're going to set the plate down on the table and scratch the mineral on the plate. And since you're doing it kind of the opposite, you need to kind of have the opposite thinking. So if the mineral scratches the plate is harder than the plate. If the mineral doesn't scratch the plate is harder than the mineral. And the reason we don't use the plate to scratch on the mineral is because, especially with the glass plates, but even with the ceramic or porcelain plates as well, if you put too much pressure on them and you break it in your hand, you run the risk of getting cut, and we don't want that. So plates stay on the table, mineral scratches on the plates, and then you just have to kind of reverse your thinking there. We'll go through some examples of this before we do the lab. The next one is fracture and cleavage. So this is how a mineral breaks. It's got 2 different ways that it can break. If it fractures, that's a random breakage, and it can be lots of different shapes. They're very irregular in shape. You're not going to have clean lines or planes. Cleavage splits along regular, well-defined planes. You're going to have clean lines and flat surfaces. Examples are sheets of mica and graphite. When those cleave, you have one direction that it's going to just peel off in a sheet, like paper thin sheets. If you look at it from the side, though, it's very irregular in shape. So it'll have fracture down one side, and it'll have the sheet cleavage at the 90-degree angle to that. Halite is a cubic example, so it's going to cleave in little cubes. It's going to look like dice, basically. It might be rectangles instead of squares, but they are very, they have 4 sides. They're very even. It's very regular. Garnet doesn't cleave at all. It fractures randomly, so there's going to be no clean lines or clean edges to it. And I've got some images on the next slide to help you see the difference. So here's our fracture versus cleavage. You have fracture on the top, so you can see there's no regular planes or lines. They're all kind of oddly shaped. Even this one over here on the left, it looks like it's smooth. It's got some indentations here that you can't really see very well. Down here on the bottom, you have cleavage. Now on the left, it doesn't look super regular, but you can see these are flat planes here. When it breaks apart in this direction, these are flat planes. This is the halite crystal here in the middle. That's a cube. And then you have another kind of cuboid cleavage here as well. So very clean lines, flat planes for cleavage, all kinds of randomness for fracture. And remember that you can have both. You can have one edge fracture and at a 90-degree angle, it will cleave. There are other properties to look at, and there's more than what we're listing here, but this is what we're going to learn about in class. We are not going to test for most of these properties for safety reasons, but you can do an acid test and take a drop of acid, hydrochloric acid, sulfuric acid, those kinds of things, and take a drop, put a drop on the mineral, and it will actually dissolve the mineral and start causing bubbles. That is a positive acid test, positive reaction. That one we are not going to test. Magnetism, we can test magnetism. It's fairly easy to do. You just take any magnet and hold it up to the rock. And if the rock is magnetic, it will either be attracted to or repelled from the magnet. Common example of that is magnetite. There are some others though. Fluorescence. We'll have some sample rocks that do have fluorescence when we do the properties lab, the mineral identification lab. I'll bring out the samples and show you those. I do have some that will fluoresce, so they basically glow under the UV lights. And it'll generally be a different color than what you see when you look at it under normal light. Sparking is a property that we're not going to test. It gives off small flashes of light when you rub it with a metallic point. So think of like rubbing a rock with a piece of flint when you're out, camping in the woods, whatever, or you've seen them do it on maybe some cartoons or TV shows, whatever. But that spark that comes off when metal scratches against something like that, that is a property of some of the minerals. Another property is whether or not it's electrical. So some minerals can become charged when they're heated or cooled. And then we're not going to test that one either. The last one is refraction, or does it bend light? So think about pool water. When you look in the pool, it kind of looks like things are bent a little bit. It's not true to their location when you look through the water at them. It's kind of the same thing with refraction. It's going to bend light. All right, so we have a quick video here to test the properties of minerals. This one, when we watched it in class, it made us actually watch it on YouTube instead of embedded here in the video or in the notes. So if that happens, totally fine. Watch it on YouTube, come back. It's all good. But go ahead and pause the video here, watch this video. It's another one, it's not super long. I think this one's about 10 minutes, and I think it does have some commercials in it occasionally, depending on how YouTube feels. If you can watch it embedded here, that's even better. But go ahead and pause me, watch this video, and then come back to me and restart my video. Okay. The next slide then is your flipbook instructions. You're going to do a flipbook over properties of minerals. So the instructions are here. If you click, it'll bring you into this minerals page. And these are the instructions on how to do the flipbook. You can also, if you'll notice, when you get out of the notes, you scroll down, you have a homework assignment. Complete the flipbook linked at the end of the presentation, also found on the assignment page here. Take a picture and upload it to the homework assignment page. So if you click the link here, it will take you to the same assignment. Okay, so let's go ahead and click that so you can see the actual assignment page in Canvas, and this is what it looks like. So these instructions are telling you to use the instructions below to make your mineral flipbook. There's a video link attached right down here, video clip, okay? That will show you what your flipbook should look like and how to make them. And then it tells you when you are finished, take a picture and upload it here to this assignment. So where mine says published, yours will say submit, and then you'll take 2 pictures of your flipbook completed, upload them here, or you can insert them into a Google Doc and upload the Google Doc. That tends to be easier for a lot of kids. Either way is fine. If you upload your pictures directly, please make sure that they are JPEG images, or I will not be able to see them and you will get a 0. Also, pay attention to this right here. I need to see at least 2 completed pages of your flipbook in order for you to earn the points for this assignment. So please make sure that you take pictures of 2 finished pages. That means the inside, the underside of the page, where I can see that you listed out all of your details of the property and your picture and all of that. We used to do this in color. I provided colored pencils in class. I provided rulers in class. I provided the stapler in class, all of that. We really can't do that anymore with COVID. So if you don't have colored pencils or crayons or something at home that you have access to, it's totally fine to do this by pen or pencil only and just have it be monotone. Totally fine. So here are your instructions. Use the internet and your notes to find characteristics for each of these properties of minerals. I gave you a website to go to that gives you all of the information you need for all of this, or you can go to the notes that we just took and use that for your information. You're gonna need 5 pieces of paper to make the flip booklet, and then down here at the bottom are your instructions. Under each flap for each property, you need this information. So you need the characteristics of the property, a picture that represents the property, doesn't have to be literal, and an example of each property. And then here's what you need. Properties and minerals that you need to include are, so there are 9 things here. You're gonna have 10 flaps on your booklet. So that first flap should be your name, and it should say minerals or mineral properties plus your name on that very first flap. Then you'll start on the second flap with the rest of this information. You can put these in any order that you'd like. There's a lot of information for what is a mineral. So you might want that to be maybe your bottom flap, so you have more room to write, because the flaps are going to be smaller at the top end of your booklet, and you'll see what I mean in just a second. So what a mineral is: luster, streak, cleavage, fracture, hardness, shape, texture, smell, and odor. Those are all items that you need in your flipbook. There's a video clip here of what your flipbook should look like. Basically what you're gonna do, and I'm gonna turn my camera on. There we go. So what you're gonna do is you're gonna take your paper. I have computer paper. You can do it with notebook paper. That's fine if that's what you've got at home. So you're going to take 5 pieces of paper, and I'm going to show you with 3, but you're going to take 5. You need 5 in order to be able to do all of your properties. So you're going to take your pieces of paper and you're going to stack them on top of each other so they're offset a little bit. So I've got, an inch and a half or so that they're offset. So I have this one here. So you can see I have, let me find a good angle here. So you can see I have 3 pieces here, 1, 2, 3, and the edges are different. Here's the edge of the first one, here's the edge of the second one, here's the edge of the third one. So 1, 2, 3. And the other end, it looks solid, but if you flip it over, you have the same edges, one here, and one here. So you have the same 3 edges. You will have 5 edges instead of 3. Okay, so line them up, offset them slightly. Then you're going to fold this whole thing in half, short end to short end. So I guess hamburger style. And then you're going to crease it. So I have my flaps here. There's 1 flap. There's my second flap. Okay. And here's my 3rd flap. So you can see my edges here. I've got 1 edge, 2nd edge, and my 3rd edge. If you turn it this way, there's a good angle. You can see them. And you open it up. You can see that inside I also have 3 edges. 1, 2, 3. Okay, there's 3 edges on the inside. There's 3 edges on the outside. Open it back up, and you can see your 3 edges here. Flip it over, and I've got my 3 edges there. Okay, so this is how you're going to have it. You've got your crease here. So your top one here is going to be your title information. So mineral properties in your name. This one down here is going to be what is a mineral, luster, then you'll have cleavage and fracture. Actually, you'll just have cleavage. Then you open it up and you have your last 5. So fracture, hardness, shape, texture, smell, and odor. Okay. You want this to stay together. So you're either going to need to put a little drop of glue under each page here along the seam to keep them in place. Or if you have a stapler, you can open it up and kind of angle your stapler in from the edge so you can get it as flat as you can to the midline and staple there along the midline. So there you go. Doesn't have to be perfect. Okay, mine is not perfect. None of them ever are, but get it as flat as you can there, so that you've got your midline stapled. One on each end is plenty. You just need it to hold its form and not separate. Okay, so now you've got your flip book that you can flip open each flap. So you have your information here. So you'll have your name of your property, and then underneath the flap is where you'll write all of that information. So characteristics, a picture, and an example. So for a picture, for luster, you might put a picture of something that's shiny. So you might put a star, or make it draw a bar of gold, something that reminds you of luster. Okay, it doesn't have to be actual luster, just reminds you of luster. For streak, please be school appropriate. Okay, I know that we all just saw the Super Bowl. Please be school appropriate with your pictures. So draw something that reminds you of a streak. Draw something, again, be school appropriate, that reminds you of cleavage, which is the even breaking. So you might draw something with very flat planes and clean lines. So be creative with your images, but be school appropriate with them. Okay. You will turn this in by opening up one of the flaps. Take a picture of the information on the flap. Make sure I can see the title of the next one also. So you'll have your fracture information up here, and it'll say hardness down here. Okay. So take a picture of this page, open it up again, take a picture of that page, and then upload both of those images to this assignment to earn your points. Okay. If you need to see a finished booklet to really kind of solidify it in your mind, there's a video clip here. So if you click this, it will link you to a video of my booklet put together. And you can see that I've labeled it and everything here, so it's a little bit easier to tell. But this is a completed booklet put together. It's not filled in yet, but it is 100% put together. So you can see that I've stacked the pages so that they're offset a little bit. There's 5 pages here. I've labeled them all. I've stapled on each end here. If you fold it over, flip it over, you can see that there's 5 more flaps on the inside. I've labeled each flap, and then when you open up the flap, that's where you're going to write your information. So at the top and above the luster, anything that's underneath the flap is where you're going to write. Okay. Super easy to do, not complicated. You can follow my demo that I just did to make this one, or you can take a look at this video that's embedded on here to see one that's labeled, so you can more clearly see the offset. This will be due as your minerals homework. So please make sure that you are working on it, getting it done. This is going to be something that you are going to study for the test. You're going to use this to study. So you'll turn it in for points and it will be helpful for you. All of this information about mineral properties is going to be on the test. What is a mineral is going to be on the test. So you will need all of this information in order to be successful on the test itself. So please do not skip this assignment. Some of you guys are really bad about not doing projects, but if you skip this project, it's only going to hurt you, okay? It's going to hurt you for points, and it's going to double whammy because you're not going to have it to study for the test. Good luck. As always, I am available by email through the Canvas inbox over here. If you have questions, comments, concerns, need to let me know something, whatever, you can get to me through the inbox over here on Canvas. So good luck, have fun. I hope you guys enjoy doing this project. It's something more hands-on, that's not just staring at your computer. And hopefully it'll help you with studying. Good luck, and I will see you next time.